Hi friends, this is your Srinivas. In this video, I am going to explain you about graphs of exponential function and its properties, and also graphs of logarithmic functions and its properties. Okay, already in the previous video we have discussed about modulus function and greatest integer function. Okay, let's see. F of x is equal to a power x, where a is an exponential function. So this exponential function will be divided into two cases. Those are f of x is equal to a power x, 0 less than a less than 1, where base lies between 0 and 1. F of x is equal to a power x, a greater than 1. Okay, of course, for first case, let us draw the graph. 0 less than a less than 1 means, for example, put a is equals to 1 by 2. For example, put a is equals to 1 by 2, then function will be changed as 1 by 2 power x. X is our independent choice. Corresponding f of x values are depending. For example, x value is 0. This becomes a power 0. As we considered a is equal to 1 by 2, this becomes 1 by 2 power 0, that is 1. Okay. For x is equal to 0, corresponding f of x value is 1. Suppose x is equals to 1. X is equals to 1 means corresponding value a power 1, that is 1 by 2 whole to the power of 1, which is nothing but 1 by 2. X is equals to 2, it becomes a square. A square is nothing but 1 by 2 whole square. 1 by 2 whole square means it is 1 by 4. X is equals to 3 means it is 1 by 8. X is equals to 4 means it is 1 by 16. X is equals to 5 means it is 1 by 32. It is coming down. And you see, for x is equals to minus 1, it is a power minus 1 is nothing but 1 by 2 whole to the power of minus 1. 1 by 2 power minus 1 means its value is 2. It goes to 2. X is equals to minus 2. 1 by 2 whole to the power of minus 2 becomes 4. X is equals to minus 3, it goes to 8. Now, the graph of an exponential function in this case will be like this. Observe that this is the graph of an exponential function. Okay. You see, as x values are increasing on x-axis, corresponding f of x values are decreasing. After certain stage, graph of a power x almost looking like coinciding with x-axis. When we say that the graph touches or intersect x-axis, for certain x value, f of x value is 0. Is there exist any such x value such that a power x is equals to 0? No. So that's why graph never touch or never intersect x-axis. Neither touch nor intersect x-axis. But by going on, as x values are increasing, graph is very closer to x-axis. Whenever it neither touch nor intersect but very closer to x-axis, we say that graph is an asymptote to x-axis. Asymptote means it is looking like a tangent to x-axis at infinity point. Okay, and you see left side on x-axis we can see only negative real numbers. For negative real numbers also graph is above x-axis. Whenever graph is above x-axis means it is taking corresponding positive y values. Okay? Now you see, graph never crosses x-axis and never be below x-axis. That's why graph never be negative. Always it is above x-axis only. But as x values are increasing from left to right, graph is coming down. Graph values, corresponding y values are coming down, decreasing. So that's why a power x in this case is always a decreasing function. Okay, let's write properties later after drawing graph for second case also. You see, f of x is equal to a power x where a greater than 1. In this case, put a is equals to 2. A value is greater than 1 means assume that a is equals to 2. Then this function becomes f of x is equals to 2 power x. Okay? For x is equal to 0, 2 power 0 becomes 1. For x is equals to 1, 2 power 1 will be 2. For x is equals to 2, corresponding f of x value 2 square is 4. For x is equals to 3, somewhere here 8. For x is equal to minus 1, it is 1 by 2. Somewhere here 1 by 2. X is equals to minus 2, it is 2 power minus 2 means 1 by 4. X is equals to minus 3, it becomes 1 by 8. 1 by 16, like this. So, this is graph of an exponential function in this case. Of course, here a left side of y-axis graph is asymptote to x-axis. As x values are increasing left to right, graph for f of x corresponding values are also increasing. That's why graph is completely increasing function in this case. Okay? Observe that graph is defined. Graph of this function in both the cases defined for all real values on x-axis. Whichever the value you consider on x-axis, for that corresponding f of x definitely exists. Here also. That's why this function is defined for all real values of x. Wherever the function is defined, such set of values is called domain of that function. As we seen here, domain of the function is set of real numbers. For all real numbers, it is defined. And also, observe the range. Range means we have to identify the boundaries of the function. Here, x-axis, here also x-axis is asymptote. Means lower boundary of the graph is x-axis. Graph is not crossing, not touching x-axis, never comes below x-axis. That's why x-axis is the lower boundary. What is upper boundary of the graph? Here it is open curve. It can be extended infinitely. Accordingly, x values considered. So that's why upper boundary does not exist. Its range is lower boundary is x-axis means y is equals to 0. Upper boundary is infinity. And it never be equals to 0 also. So that's why its minimum value cannot be equal to 0 also. And how to check whether the function is 1, 1 or not? To check function is 1, 1 or not through the graph, we have to draw a line parallel to x-axis. This is the line parallel to x-axis. This is the line parallel to x-axis. So whichever the line parallel to x-axis you draw, if such line is intersecting the graph at only one point, we can say that it is 1, 1. If it is intersecting the graph more than 1 points, it is not 1, 1. Observe that even in this case also, if we draw a line parallel to x-axis, it is intersecting the graph at only 1 point. Whichever the line you draw, but parallel to x-axis is intersecting the graph at only 1 point. That's why it is always 1, 1 function. Is it periodic? No. To say that function is periodic, its graph should be repeated after certain interval. So no such situation here, that's why it is not periodic. But in this case, it is decreasing function. In this case, it is increasing function. We can also identify one nature through the graph. If a graph of a function is completely increasing function, either increasing function or decreasing function, we can say that it is 1. Okay? Now you see, its properties are x is equals to a power x, domain is equals to R, range is equals to open interval 0 comma infinity. Why not closed interval 0 to infinity open? It cannot be equals to 0 also. What is its minimum value? Minimum value is 0. Maximum value does not exist. And f of x is equals to a power x is always 1 function. Is always 1 function. F of x is equals to a power x 0 less than a less than 1 is always decreasing function. F of x is equals to a power x, a greater than 1 is always an increasing function. Already we have seen this. And f of x is equals to a power x is not a periodic function. So these are the properties about exponential function. And see, our next function is logarithmic function. Okay? A function f of x defined as log x base a is called a logarithmic function. Okay? Based on base of a logarithmic function, here also two cases. One is log x base a where 0 less than a less than 1. Other one is f of x is equals to log x base a when a greater than 1. Okay? Now you see the graph of logarithmic function. Suppose a value 1/2, for example, it lies between 0 and 1. Now it is looking like log x base 1/2. Here x is a variable, that is our independent choice. Put x is equals to 1, log 1 base anything is always 0. Put x is equals to 2, it becomes log 2 base 1/2 is -1. Somewhere here. Put x is equals to 4, it is -2. Somewhere here. Put x is equals to 1/2, it is 1. 1/4, it is 2. 1/8, it is 3. So, this will be the graph of a logarithmic function in this case. Observe that in the previous function, exponential function, f of x is equal to a power x, base is 0 less than a less than 1. Graph of your function is asymptote with x-axis. Now the graph of your function is asymptote with y-axis. Now let's go to second case of the same function, logarithmic function. See, for example, put a is equals to 2. Whenever a is equals to 2, it becomes f of x is equals to log x base 2. Log x base 2, as we consider x is equals to 2, it becomes log 2 base 2. Log 2 base 2 value is 1. And log 1 base 2 value is 0. Log 1 by 2 base 2 value is minus 1. Log 1 by 4 base 2 is minus 2 somewhere here. Log 1 by 8 base 2 is minus 3 somewhere here. So in this case, this is the graph of logarithmic function. Observe that here graph of logarithmic function is asymptote to negative y-axis. So a power x log x base a having close relation. Their graphs are symmetric about the line y is equals to x because both of they are inverse functions to each other. As we discussed earlier, can you check whether it is 1, 1 or not? 1, 1 nature can be decided by drawing a line parallel to x-axis. As it is intersecting the graph at only one point, it is always 1, 1 function. And observe, the domain means for what values of x function is defined. At 0 function is undefined. Why? Because graph never be coincide with y-axis. 0 to right side, whichever the value you consider, graph is always defined. 0 to right side, wherever you go, for such values graph is defined. 0 to left side, there is no graph. Means f of x is equal to log x base a is defined for only positive real numbers. For only positive real numbers. And what are the boundaries of this graph? There is no lower boundary. It goes to till to minus infinity. And there is no upper boundary. It is always 1, 1 function. Is it periodic? No. It is not periodic. What about increasing, decreasing nature? As x values are increasing in this case, graph is coming down. It is decreasing function. As x values are increasing, graph values are also increasing. So that's why in this case it is decreasing function, in this case it is increasing function. So whichever the case, graph is always 1, 1. Domain is always positive real numbers. Range minus infinity to plus infinity. There is no minimum value, no maximum value. It is not a periodic function because its graph never be repeated after a certain stage. So these are the cases. Now, I will write properties. See the properties. F of x is equal to log x base a. As we seen through the graph, always it is defined for right side to the origin on x-axis values only. That's why domain is 0, infinity can also be written as or plus. Range, there is no upper boundary, there is no lower boundary. That's why range is minus infinity to plus infinity. So that its minimum value does not exist, maximum value does not exist. F of x is equal to log x base a. Depending upon base value, it is either decreasing or increasing. It is 0 less than a less than 1, decreasing function. As a is greater than 1, it is always increasing function. Of course, already we have seen. That's why it is 1, 1 function. F of x is equal to log x base a. 0 less than a less than 1, decreasing. A greater than 1 is increasing. F of x is equal to log x base a is not a periodic function because its graph never be repeated after a certain stage. Of course, we can also draw the graph of logarithmic function without lifting marker from the board on its domain. Okay, that's why it is continuous on each and every point on its domain. F of x is equal to log x base a is differentiable on 0, infinity. means on its domain. Also, a power x log x base a both are inverse functions to each other. Okay, so these are the properties of logarithmic function and their graphs. Okay, see, if you like my video, please do subscribe and share, and leave a comment on comment box also. Okay, please encourage me to do more videos for you. Okay, thank you friends.